The Faculty of Technology, University of Sri Jayawardenepura, Sri Lanka's pioneer in technology education, is an institution of excellence. This flagship Faculty of Technology is one of the infant faculties of the renowned University of Sri Jayawardenepura. Established in 2016, the faculty stems from rich roots of innovative thinking. The faculty is in many ways a result to the solution of creating employable graduates to fit the needs of the modern industry upon the introduction of the stream of Science for Technology for GCE advanced level students. The University of Sri Jayawardenepura was the first to provide further education to those who will pass out from the stream. Thus, the Faculty of Technology was born by indirectly paying homage to the most venerable Valavitiye Sri Solatha, who once performed a similar service when establishing the Vidyodaya University, which is our legacy. The faculty has come a long way from its humble beginning in 2016, where it functioned at a modestly facilitated building in the heart of Vijayarama. Today, it has developed into a staggeringly large complex equipped with some of the country's best equipment in a grander and much larger location in Pitipana. Having begun with just 3 departments, Department of Biosystems Technology, Engineering Technology, and the Department of Information and Communication Technology, today, it has expanded to a 5-department faculty with the divergence of the Department of Engineering Technology to the Department of Civil and Environmental Technology and Department of Materials and Mechanical Technology, and the further introduction of the Department of Science for Technology to the faculty. These departments offer Bachelor of Technology Honours degrees from highly demanded focus areas. These full-time 4-year degree programs are professional programs which offer a highly recognized degree of level 6 under the Sri Lanka qualification framework. The highly qualified staff recruited to the faculty, spanning from multiple disciplines, is the crown jewel of the faculty. It boasts over 130 employees from both academic and non-academic fields, out of which over 50 academic staff members are holders of PhDs from recognized universities from all over the world. Their commitment to their field and their curiosity towards the NIB has allowed them to help the faculty earn its place on the map. The faculty, that was once home for just 322 students, has now grown to accommodate over 1,200 students, with the ambition of expanding its reach to house more than 2,000 students in the near future. The modern hostel facilities in the faculty ensures that all needs of accommodation are fulfilled for the students of the faculty. Students of the Faculty of Technology are avid inventors participating in many events that foster their invention and innovation skills. In a few short years, the faculty has become the front runner in technology-based research and is now the proud publisher of the scientific journal Advances in Technology. The Faculty of Technology, University of Sri Jayawardenepura, was the vision and the dream of many individuals. It was held high upon the shoulders of many leaders. Today, it is the pride of Sri Lankan technology education.
Good evening. Can you hear me?
Good evening, sir.
Okay. Are you clear my sound and our board? No issue, right?
Yes, sir.
Clear, right? Good job. Har. Okay. Okay, we are discussing about Vernier caliper, right? Okay, actually, this is our second lesson of our syllabus. In this lesson, we are discussing about measuring instruments. I will give you brief introduction about our lesson for new students. Okay. First of all, we have 25 lessons in our syllabus. We have 25 lessons. Out of these 25 lessons, these 25 lessons, we can classify it into 5 areas. 5 areas. If you are new students, you can watch our first day recording. I have explained everything. I had explained all categories and each and every lesson components. What are the parts we discussing, and what are the areas, and what are the future opportunities and higher education opportunities, scholarship opportunities, and job opportunities. Everything I have explained in the introduction session. You can watch this video. Okay, now, okay, what are the 5 areas? We have physics, we have chemistry, and ICT, maths, and biology. Actually, this is a collection, actually mixture. This collection have developed, have designed, this subject have designed for match to your technology subject, main second subject. Okay, to understand these basic applications, not actually basic application, deep applications in your technology subject, the basic knowledge improving in our science for technology. The name also given, science for technology. Science for technology. Okay, that's the purpose of this subject. That's the purpose. And okay, this is the distribution. 25 lessons. We have 8 physics lessons, 6 chemistry lessons, 4 ICT lessons, 5 maths lessons, and 2 biology lessons. Biology lessons only 2. Okay. If you missed our introduction session, please go through that and understand everything about the background of the subject first and your stream and technology stream. Okay, that's the background. Okay, I told the main bulk part is a physics, right? In our stream, in our subject, the bulk part, we have 8 lessons. Okay, that's why our first lesson is measurement and measuring instruments. That's our first physics lesson. Our first lesson, actually it is second lesson, but in physics part, this is the first lesson. Physics part, this is the first lesson, measurement and measuring instruments. Measurement and measuring instruments. In measurements and measuring instrument lesson, last week I explained, we discussed 3 main type of instruments, right? What are the types? Measuring instruments. Measuring instrument. Measuring instrument. Measuring instruments, mainly 3 types. There are more than 3 types, but in our syllabus we discussing only 3 types. 3 types of instruments. What are them? One are they? Length measuring instrument, mass measuring instruments, and time measuring instruments. Time measuring instruments. If you are new students, please go through our last week video, and you can complete the basic background of the measurement lesson. In introduction session, you can understand the background of the subject and stream. Next, last week video, if you watch last week video, you can understand the background of the measurement lesson. Okay, I told for length measuring instruments, we can use four main types of instruments. Remember? Shivan? Remember? What are the instruments? Meter ruler, Vernier caliper, micrometer, screw gauge. What else? What else? Micrometer, screw gauge. What else? Very good. Traveling microscope. Traveling microscope. You can send me answers in your common chat or private chat. Any method. I can read it. I can read it. Yeah, they are the length measuring instruments. Okay, last week lesson. Okay, I just revise you. Okay, mass measuring instruments. What are the mass measuring instruments? Yeah, triple beam balance and electronic balance. Yes. Time measuring instruments. What are the instruments we use to measure time? Stopwatch. Good. Stopwatch. Stopwatch. I told stopwatch there are two types: digital stopwatch and analog stopwatch. Okay, that's a summary of the lesson. Okay, now what we doing today? Not actually today. Last day, what we did? We start to discuss one by one instruments. No, one by one instrument. Okay, therefore, last week we discussed the basic part of the Vernier caliper. Basic part Vernier caliper and meter ruler. No, meter ruler is very simple thing. Actually, the first one is after meter ruler we came to Vernier caliper. Vernier caliper. Okay, today our lesson, the second part of the Vernier caliper. Second part of the Vernier caliper. Okay, do you remember what we discussed in Vernier caliper? What's the principle of the Vernier caliper? What are the principle? What's the principle of the Vernier caliper? How many scales in Vernier caliper? Two, no? What are the scales? What are the scales? Two types of scale in Vernier caliper. What are the scales? Yan Silu, did you watch the video? Video එක Very good. Very good. Good. Okay, what are the two scales? Main scale and Vernier scale. Very, very good. Main scale and Vernier scale. I told the main scale is designed like this. Main scale. It is just same to our ruler, right? It just same to our ruler. Very good. Lot of answers. I read. Yeah, all are correct. All are correct. All are correct. Good. Okay, that's the main scale. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's just same as your ruler. They are millimeters. 11, 12, 13, 14, 15, 16, 17. What is the maximum value of main scale? Do you remember? What's the maximum value of main scale? That means actual length of the main scale. Very good. 150 millimeters or 15 centimeters. Very, very good. 15 centimeters, 150 millimeters. I hope you all working according to given plan last week. I have given a plan for you. Okay. What's the plan? Every day you have to get at least 45 minutes per one subject. And you have to continue with your other work, with your other enjoying and other hobbies, everything. With everything, doing everything, you have to get at least 30 minutes. Not 30, 45 minutes for all subjects. ETOBST, SFT, and your third subject, at least you have to get 45 minutes. Then it is A level very simple. Everyone you can get island rank, good island rank without any tough working. Final days. For final days, if you continue this pattern and working style, definitely you can get good result at the end of this journey. Okay, therefore, if you not started yet, please start. Adum patan ganda with not classes. I told you self-working. Classes you go in different classes more than 2 hour. So huge time, long time. But you have to get at least 45 minutes per one subject. Your self-studying time. Self-studying. You have to again recover and revise what we discussed last week class. That's only. And if you have any calculation, you can again try this calculation. No? Okay, that's the method. Hurry. Okay, that's the main scale. Okay, what's the main principle? I told some particular segment on the main scale, like the common one, 9 millimeter. No? 9 millimeter on main scale, divide into 10 identical parts. 10 identical parts using another linear scale. And it is movable, right? This short scale is movable. It's sliding part. It's a part of sliding job. Okay, what's the name of this second scale? This main scale. What's the name of this second scale? Very good, Vernier scale. This is Vernier scale. That's the basic principle of the Vernier caliper. I'm not going to explain everything last week class. Okay, if anyone missed last week class, please go through again last week video and complete Vernier caliper part. Okay, this instrument is very important for our future lessons as well. That's why we're discussing very important. This measurement lesson, that's why we select to discuss as first lesson measuring instruments. This is very important for our future physics lessons as well. Anit Israha lessons are done. Now this is the principle. Some particular segment on main scale divide into identical parts. According to this instrument, 9 millimeter segment on main scale divide into 10 identical parts. 10 identical parts, right? 10 identical parts. Hurry. Now, do we remember parts of the Vernier caliper? Do you remember parts of the Vernier caliper? Okay. Now, first, before go to today part, let's revise parts of the Vernier caliper. Give me a second. Okay. Can you see my screen? Yes, you can, right? Hurry. Now I will show you the part. If you can on your mic, you can tell me. on කරන්න බැරි නම් message එකක් විදිහට දාන්න. If you can turn on your mic, please tell me what is the part. Okay. What is the name of this nut? What's the name of this nut? හරි. on කරන්න පුළුවන් අය කියන්න. What's the name of this nut? What's the name of this nut? Very good. A lot of messages. Yeah. Message all are correct. Yes. This is a screw nut. Very good. This is a screw nut. Screw nut. Or locking screw nut. Very good. Locking screw nut. Good. And what is this sliding scale? This one. This moving scale. What's the name? Very good. It is Vernier scale. Very good. Vernier scale. Vernier scale. Vernier scale. Vernier scale. Before that, who didn't receive your tutes? I think more than 10 students confirm me they have got the tute back. One student informed they didn't receive xenon, no? Others, if anyone not received, please send me message. Anith හැමෝම ගත්තද tute pack? Ashini Edirivi. New students, okay, you can get within 3 days. Asandu. Okay, let me check. Others, everything okay. Kalindu, you got the tute. I also got tute. Then only xenon is a problem. Xenon, I will post again your tute. Actually, you only have a problem. Yeah, එක්කෙනෙක්ගේ හම්බෙලා නැත්තේ නේද? හරි. No issue. හරි. What is this jaws? What are the name of these jaws?
Exterior jaw.
Very good. External jaws. External jaws. Very good. What are the name of these jaws?
Inner jaw.
Yes, internal jaws or inner jaws. Both correct. And what's the name of these rod? What's the name of this
Depth
rod?
measuring.
Depth measuring. What? Next word. Depth measuring with right. Depth measuring strip or depth measuring rod. Depth measuring rod. Depth measuring rod. Depth measuring rod. Yeah, you all correct. ගොඩාක් message එන මට සමහරව කියවන්න බෑ. Depth measuring rods. And what is this long scale? This one. Fixed one. Fixed
Main
is
scale.
very good. It is main scale. Main scale. And very good. Main scale. Hard. Good, Hashim. Main scale. And yeah, they are the main parts. And there is a wheel here. It is not
Sliding
given
wheel.
in. Yeah, sliding wheel. Sliding wheel. Very good. Sliding wheel. Sliding wheel. Hard. Do you remember what's the purpose of this sliding wheel? I'll stop this sharing. Okay, this is the instrument. Okay, they are the parts. They are the part. This is a depth measuring strip. Depth measuring strip. Yeah, depth measuring strip. This is a depth measuring strip, and this is the screw nut. Screw nut, and they are the external jaws. External jaws. What is the purpose of external jaws? Do you remember? The purpose of external jaws?
To measure outside of the object
Outside what?
with
Yeah, width or diameter, no? Width or diameter. Yeah, that's the purpose, to measure external diameter like this. That's the purpose. External diameter. External diameter. External diameter. What's the purpose of this internal jaws? They are the internal
measure
jaws
the
or
inner
inner.
diameter.
Yeah, to measure internal diameter, inner diameter. Very good. To measure inner diameter like this. What's the purpose of depth measuring strip?
To measure the depth of a object
Yeah, to measure the depth of any hole, right? To measure depth of any hole like this. Okay, finally, we discussed how to read measurements using Vernier caliper. How to read, still I am revising last week lesson, okay? Last week I explained, finally I explained about how to read measurements using main scale and Vernier scale in the Vernier caliper. Please, can you read quickly this reading? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it's continue. Okay. Ten. Okay. Can you read this measurement? Okay. Please read and send as a message. Don't tell me. Send only as a message in chat. Others, only 2, 3, Don't need this 15. It's 15, correct, but don't need this value. Step please check again. Asandu, please check again. Good, 7 correct, 7 correct. Hari. Do you remember last week I explained 4 main steps to read any measurement using main Vernier caliper. Hari. I explained 4 main methods. Okay, this is the first method. What's the first method? Read the main scale reading. Main scale reading. Okay, what's the main scale reading? What's the main scale reading? Always main scale reading is the main scale value before Vernier scale 0. You can count 0, 1, 2, 3, 4, 5 is the 5 millimeter is the main scale reading. 5 millimeter is the main scale reading. Second step, Vernier scale coincide parts. Coincide parts. Vernier scale coincide parts. Vernier scale coincide parts. Vernier scale coincide part. Okay, how to get these coincide parts in Vernier scale? Okay, not main scale. Now main scale is completed. Now coincide parts on main scale. Okay, how to calculate? How to count coincide parts? 0, 1, 2, 3, 4 not coincide, 5 not coincide, 6 not coincide, 7 not coincide, but 8 coincide, right? 8 coincide. 8 is the coincide part. Mother, you can't forget, because today lesson these readings, measurement reading compulsory. If not, you can't understand today 0 error lesson. Vernier scale coincide part. Third one, coincide parts, that means 8 coincide parts multiply by least count. Okay, I told last week we discussed what's the meaning of the least count of the Vernier caliper. If it is 10 Vernier scale part, what is the least count? If it is 10 Vernier scale parts, what's the least count? If it is 10 Vernier scale parts, what is the least count? It is? No, Shena. 0.1 millimeter, yes. Least count. 0.1 millimeter. Least count. What's the meaning of the least count then? What's the meaning of the least count? The minimum measurement that can be accurately measured by any Vernier caliper. That's the least count of the Vernier caliper. Zero 0.1, then 8 multiplied by 0.1. 8 multiplied by 0.1. It is 0.8, right? 0.8 millimeter. 0.8 millimeter. Now, what's the final reading? Final reading. What's the final reading? This 5, the first step answer or main scale reading, add to the Vernier scale this multiplied value 0.8. Third step answer. It is 5.8 millimeter. 5.8 millimeter. Yeah, what happened? Okay, I'll give you another reading. You have to read now. Within 30 seconds, you have to read. Okay, they are the steps. First, get the main scale reading. How to get main scale reading? The previous value on the main scale before start Vernier 0. Again, Vernier 0 position previous value. Previous value to the main scale, Vernier scale 0. And how to get coincide part on main scale, sorry, Vernier scale, not by main scale. Get the coincide. Coincide means it's aligned with one main scale value, like this, align. Maybe they'll one line that's the meaning of coincide. In the third step, this coincide number multiplied by the least count. Multiplied by the least count. Finally, this multiplied value add to the previous main scale value. I got steps. Could you revise? Last week we discussed. Anyone? If you have any doubt, please ask me. Anyone, if you have doubt, please ask me. Who is new student? Hashini. You new student, right? Could you understand? Second one. In second one, what we doing? This is a Vernier scale, right? This is a Vernier scale. First one, okay. First, the main scale reading is the main scale value before Vernier scale 0. Before Vernier scale 0. Least count. Can you watch previous last week recording? Now think the least count is a minimum reading that can be get accurately by any instrument. If you got your ruler, okay, normal meter ruler or your ruler, its least count 1 millimeter. That's a minimum reading that we can get accurately by ruler. For this Vernier caliper, it is 0.1 millimeter. 0.1 millimeter means 1 millimeter divided into 10 parts. I will give you all recordings, previous recordings. Then you can complete, don't worry. Okay, now try to understand. Now try to understand only measurement reading. First get the main scale reading. How to get the main scale value? The main scale value before start Vernier scale 0. This is a Vernier scale 0. Then you can get the main scale reading. Main scale reading, what happened? Okay, main scale is done. Main scale reading 0, 1, 2, 3, 4, 5. It is 5. That's first step. Second step, count Vernier scale part until align one value with main scale reading, main scale value. 0 not coincide. It is not aligned to any main scale value. 1 not coincide, 2 not coincide, 3 not, 4 not, 5 not, 6 not, 7 not, but 8 is aligned with main scale value, no? Then coincide part 8. Akil. Akil or Akil. Could you understand? I got Akil. Sorry, I can't pronounce your name correct. Okay. In third step, what we doing? This coincide parts multiplied by the least count. Least count. If you can't understand least count calculation, go to last week video. For now, you can remember if it is 10 Vernier scale parts, it's always 0.1. It's always 0.1. Then multiply by coincide number, it is 0.8. Finally, this 5 plus 0.1, 0.8 at this main scale value and multiplied value. It's 5.8 is a final reading. I will give you second one. Let's go into second one. What is this reading? What is this reading? Please follow these steps. Please follow previous steps. Quickly. Okay, for first one, I will help you. Okay, what's the first step? What's the first step? Calculate the main scale reading. Hurry. Main scale reading is ikman. Tell me what is the main scale reading? Main scale reading. Yeah. Yeah. Don't take centimeters. It's 0. First understand this one. Sorry, first understand this one. This scale, about this scale. Always try to get millimeters. If it is given centimeters, then 0.5 means 5 millimeters actually. Mean 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 1 centimeter. 1 centimeter. It is same as your ruler. 11, 12, 13, 14, 15. 15 is a 1.5 centimeters. Don't think in centimeters, always think only millimeters. Hurry, millimeters value. Tell me what is the main scale value? What's the main scale reading? Millimeters, in millimeters. Millimeters can. Good, Hashini. Others? Millimeters only. No, Shiva. Try to get millimeters, only millimeters. Don't take by centimeters. Millimeters, only millimeters, Shiva. Yes, Sanon correct. No, Kalidu. Check again. Main scale value I need. Main scale reading. What's the main scale reading? Hurry. Remember, this is a Vernier scale 0. It is very simple. This is a Vernier scale 0. This is a Vernier scale 0. Then what is the main scale reading? The previous value. This is the previous value. Then you can count. You can count. Up to now 5, 6, 7 millimeter. 7 millimeter is the main scale reading. Hurry. Ek doubt ekak tiyena, send me message if you have any doubt to get the main scale reading. Yeah, now correct, Shiva. Yeah, main scale reading 7 millimeters. 7 millimeters. Now, what is the next step? Get the coincide number. Where we need to count coincide number? On Vernier scale, not main scale. Then 0, 1 not coincide, 2 not coincide, 3 not coincide, 4 not coincide, but 5, 5 coincide. 5 coincide, then 5 multiplied by 0.1. It is 0.5. Now 7 plus 0.5, it is 7.5 millimeter is the reading. Still, if you have doubt, please send. Some doubts because that's very important for today lesson. If you can't read measurements, today you can't understand your today lesson. Let's say again and again I am explaining. Hurry. No doubts, right? No doubts, no doubts. No doubts. Okay. Quickly calculate this reading. Okay, this one, sorry, not this one. Okay, quickly calculate this reading. Can you understand? Can you count? Yeah, it's clear, right? You can see coincide numbers. Yeah, that's the read. Please read this. Please first follow your steps. Follow, I given 4 steps. Then when you practice, you can get directly the answer without step. But now please try to follow steps. Good, Senon. Hashini, you have to mention unit as well. Good, Akhil. Now get the final answer. Get final answer. Good, Sheban. No, Yansil. Yansil, check again. Yes, Akhil, correct. You have to mention the unit. Hashini, correct. Teumin, correct. Tarindi, correct. Hassandu, please check again. Okay, let's follow steps. Okay, what are the steps? First, get the main scale reading. This is a Vernier scale 0. This is a Vernier scale 0. No, Yansalu. Yansilu. Hari. May අල්ලගන්න මේ steps ටික. Please follow these steps. Okay, this is the Vernier scale 0. And if it is, okay, this is a Vernier scale 0 and this is a main scale reading actually. This is a reading. Okay, if it is 1 centimeter, they are centimeters, no? They are centimeters, okay? Then 1 centimeter means 10 millimeters, 11 millimeters, 12 millimeters, 13 millimeters. Yeah, 13 millimeter is the previous value of Vernier scale 0. Yeah, this is a Vernier scale 0. This is 13 millimeter. Then what's the second step? Get the coincide. Jansidu, Baranda. Get the coincide number. Okay. Please count. 6 not coincide, 7 not coincide, but 8. 8 is coincide. 8 coincide. Now 8 multiplied by 0.1, it is 0.8. 0.8 plus 13, 13.8 millimeter. Yansil, what happened? And Hasandu. Now okay? Then Terma. Yeah, main scale reading is important, Hasandu. See, don't think these values are centimeters. Are the centimeters? Don't think by centimeters. Always convert into millimeters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 centimeter means 10 millimeters. Then 10, 11, 12, 13. 13 millimeter is the main scale reading because this is a Vernier scale 0. Main scale reading එක කියන්නේ Vernier scale reading එකට previous one. Yeah, this is 13 millimeter is a reading. Main scale reading. Second step, coincide part 8. 8 multiplied by 0.1, it is 0.8. 0.8 plus 13, it is 13.8. Millimeters. Millimeters, millimeters. If you want in centimeters, you can convert 13.8 mean divide by 10. 1.38 centimeters. Don't think by centimeters. Yeah, that's a problem. ඒක තමයි එපා කිව්වේ. Only think millimeters. If you read millimeter reading, you can convert into centimeter or meter, you can convert. Don't worry. Please do your reading process by millimeters, otherwise you will confuse. Hurry. Final one. Final one. Very good, Hasan. Very, very good. Perfect. Not okay. Please check again. This coincide number is a problem. Yanselu, again same issue. 2 is not 2 millimeter. Yanselu, point එක හදාගන්න, that's your problem. Others are correct. You got the idea? Yes. Amin correct. Ashini correct. No, okay. Check your coincide number. Tarindi correct. Shivan correct. Senon, small mistake. Check your coincide number. Now correct, Jansi. Always millimeters, millimeters. Then if you want, you can convert into centimeter. Now correct, okay. Now correct, Seno. Hurry. Now everything, everyone correct. Hurry. Now we can go to final one. This one. This is a Vernier 0, this is not the 0. Remember. Very good, Hazulu. Tevmin, very good. Shivan, very good. Senon, very good. Okay. Please, yeah, very small mistake. Please check your main scale. Main scale reading. Jansilu correct. Very good. Tarindi correct. Very good. Hashini correct. Very good. Now correct. Very good. This is not the Vernier scale 0. This is the edge of the Vernier scale. This is edge. This is a Vernier scale 0. Then 20, 21, 22, 23 millimeter is the main scale value. Okay, perfect. Perfect, perfect. Okay, let's move into today's lesson. Let's move into today's lesson. Okay, our today lesson, the zero error of the Vernier caliper. The zero error of the Vernier caliper. Hari. Okay, before discuss the zero error of Vernier caliper, do you know what's the meaning of the zero error of any instrument? Any measuring instrument, what's the meaning of the zero error? What's a zero error? It's just error of the zero, no? Zero error, error of the zero. Do you have any idea? Zero error. Zero error. Okay, I will explain that by very simple examples. Okay, now you are going to buy 1 kilogram of sugar. Had the seen kilo ekak. You are going to buy 1 kilogram of sugar from whatever shop. Think supermarket kills or whatever supermarket, you are going to buy 1 kilogram of sugar. Okay, your requirement, buy 1 kilogram of sugar. Okay, now when you go into supermarket, this is a digital screen, digital what we called as a electronic balance. Sorry, this is the electronic balance of the supermarket with digital screen, and this is a measuring pan. This is a measuring pan, and you can see on this digital screen, before put anything on this measuring pan, you can see this, it has a measurement. It has a measurement like this. It's given measurement like this. Then using this instrument, if you measure 1 kilogram of sugar, can you get accurate reading? Can you get accurately 1 kilogram of sugar? Can you get accurately 1 kilogram of sugar? Seen kilo ekak mahambed. No, actually, if you measure 1 kilogram of sugar by this instrument, actually you can get 995 grams. 995 grams. Yeah, actually, you can get only 995 grams. Yes, very good. Yes, very good. Okay. Now, another day, again you're going to buy 1 kilogram of something using same supermarket. Hurry, another day. Okay, now you can see before put anything on the measuring pan, you can see the reading is 0 now. Now if you measure 1 kilogram, can you get accurately? Can you get accurately 1 kilogram? Now okay, very good. Now okay, now you can get 1 kilogram. Yes, good. Now you can get 1 kilogram accurate. Hi, very good. Now instrument is correct. Okay, you are going another day. Think you're going another day. Now you can see this type measurement before put anything on the main scale. Now what happened? Can you get accurately? Yeah, you can't get accurate reading. Now tell me, if you buy 1 kilogram, if you buy 1 kilogram, how many grams you will have? You can have how many grams? Kochara hambe? Yes, very good. You can get 1005, no? 1005. Yes, 1005 grams. Additional 5 grams. Additional 5 grams. Additional 5 grams. Very good. Very good. Okay, that's a zero error. That's a zero error actually. That's a zero error. Okay, now you have to remember what's a zero error definition. It's very simple, me. Very simple. The zero error definition, remember, before take the instrument showing some value when no measurement is taken. When no measurement is taken, no anything on the measuring pan, but if it is showing some value, this is a zero error. This is a zero error. Then if it is no any zero error, it should be zero. If it should be zero. Okay, go to the tute. That's a very basic idea. Okay, now again tell me what's the basic idea of the zero error. When no measurement is taken, measurement එකක් ගන්න නැති වෙලාවෙත්, when no measurement is taken, if it is not showing zero reading, if any instrument not showing zero reading, that is the zero error of any instrument, not only vernier caliper or electronic balance. Any instrument, the instrument showing some value without zero when no measurement is taken. Measurement එකක් ගන්න නැති වෙලාවේදී without zero, if this instrument showing any value plus or minus or whatever value without zero, that we called as a zero error. That we called as a zero error. Hari? Okay, got the tute. If you don't have tute, please, okay, I will solve your problem before next Sunday. Definitely, I will solve your all problems. New students, yeah, අපේ හිටියා again Xenon විතරයි මම හිතන්නේ. Only Xenon have a problem. Others, okay, new students, you can get tutes before next day. Okay, read the definition. If any instrument does not showing a zero reading when no measurement is taken, that is a zero error of any instrument. Please highlight. If any instrument does not showing a zero reading when no measurement is taken, what's the meaning of this calibration error? That's a similar word for zero error that we called as the instrument has a calibration error. The calibration error means zero error. It is similar word of calibration error. Calibration error. It's a similar word. Calibration error. Calibration error. Okay. Now, what's the zero error of any instrument? If any instrument does not showing a zero reading when no measurement is taking. While no measurement is taking, the instrument not showing the zero reading. Understood? That we called as calibration error or zero error. The error of the zero. Understood? That is common for all instruments, not only vernier caliper, electronic balance. It is for all instruments. All measuring instrument. That's a zero error. That's a zero error. That's a zero error. Can you share the PDF of tute? Yeah. I can send you what's your number. Yeah, I have saved you, I think. Ashini Edirsi. Yeah, I have contact. Okay. I got. What's the meaning of the zero error? Any instrument shows some value when no measurement is taken, that we called as a calibration error or zero error. Okay, now the same principle if you apply to vernier caliper, what's the meaning of the zero error? What's the meaning of the zero error of vernier caliper? What's the meaning of zero error of vernier caliper? Vernier caliper? Give me a second. Sorry. Yes. Good. Yeah. Okay. Now what's the zero error of any instrument when if any instrument does not showing a zero reading when no measurement is taken? Without taking any measurement, if it is not showing zero reading, that we called as a calibration error or zero error. Now, if you come to the vernier caliper, what is the zero error? What's the zero error of vernier caliper? Okay, what is the status? What's the state when no measurement taking by vernier caliper? Vernier caliper, no measurement is taking mean the contacting external jaws. Okay, now no measurement is taken, right? No measurement is taken. While contact two external jaws. Contact two external jaws like this. If it is not showing zero reading, that we called as a vernier, zero error of the vernier caliper. I got me bala. If the zero error of vernier main scale, sorry, if the zero of the main scale does not parallel or coincide with the zero of the vernier scale, when the jaws of the vernier caliper are aligned, that means jaws of the vernier caliper contact, then the instrument has a zero error. That's the meaning of the zero error. Now you can remember what's the meaning of the zero error of any instrument without taking measurement if it is showing any reading, right? If it is showing any reading without zero, that's a zero error. Vernier caliper, this is the case. Very simple. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now understand. Using vernier caliper, no measurement is taking mean. No measurement taking mean. These external jaws contact each other. The position of external jaws contact each other. When external jaws contact like this, contact each other, main scale 0 perfectly, if it is main scale 0, perfectly coincide with the vernier scale 0, we call this instrument, there is no any zero error, this is accurate instrument. This is accurate instrument. I got main while contacting external jaws of the vernier caliper, main scale 0 perfectly coincide with vernier scale 0, that we call instrument no any zero error. It is accurate instruments. Up to now, okay. I will show you. I will show you accurate instrument. Accurate instrument. Okay. Now, what is the meaning of no measurement taking by vernier caliper? The contact. Two external jaws contacting. Now it is contact. Okay. When it is contact, main scale 0 perfectly coincide with vernier scale 0. If it is perfectly if it is perfectly coincide main scale 0 with vernier scale 0, that we called as that we call no any zero errors. That is accurate state, accurate instrument. I got no any zero error. Now, when no measurement is taking, the instrument showing zero reading, no zero errors. I got up to now. There. No measurement is taking, the instrument showing zero reading. Understood? Hari. Then what is the meaning of now this instrument no any zero error? Now what's the meaning of the zero error? If it is contact two external jaws, if it is not coincide, main scale 0 not perfectly coincide with vernier scale 0, that we called as a zero error of vernier caliper. That is a zero error of vernier caliper. It is not perfectly coincide with main scale 0. I got that is a zero error of vernier caliper. Teruna. Done? Send me message. Kalindu. If it is coincide while contacting, made in a contact with the while contacting external jaws, if it is perfectly coincide, no any doubt. This instrument, no any zero error because it is showing zero reading. It's showing zero reading. Therefore, no any zero error. No zero error. No zero error. This is physics. You can't by heart. You have to understand. No zero error. It's accurate instrument. Accurate instrument. Accurate instrument, right? Then what is the meaning of the zero error? If it is not coincide while contact external jaws, if it is per main scale 0 not coincide with main vernier scale 0, that is a zero error of vernier caliper. Hari, please send me message if you understood up to now. Hari, very good. Hari, point එක කරගෙන යන්න. හරි. Hari. Now the go to tute. All okay. Now go to table. Yes. The two main types of zero error in the Vernier scale. Yes. Do you remember in electronic balance example? Electronic balance, I explained two main errors, no? Two main types of errors. One, first error type, you got only 995 gram. Second chance, you got 1005 grams. Okay, the same thing. Two main types of zero errors of Vernier caliper. Yes. Okay, highlight the first one positive zero error, the second one negative zero error. The first one positive zero error, the second one negative zero error. The positive zero error and negative zero error. Positive zero error and negative zero error. Okay. What's the meaning of the positive zero error first? What's the meaning of the positive zero error? Okay, try to focus very well. Very important. Okay. Positive zero error. Positive zero error. What's the meaning of the positive zero error? Positive zero error means while contact this external jaws, like this, what happened? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, it is continue up to 150 millimeters. Now what happened? While contacting these two external jaws, the Vernier scale locate like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this. While contacting two external jaws of Vernier caliper, the Vernier scale 0 shift right side than the main scale 0. See, shift right side than the main scale 0. That is the positive zero error. That is the positive zero error. Okay, what do you think? What are the reasons for this positive zero error? Don't write anything. See, when the outer jaws of Vernier caliper touch each other, outer jaws mean external jaws. Outer jaws of Vernier caliper touch each other, the zero on the Vernier scale shift to the right or ahead. Ahead mean ඉස්සරහට කියන එක නේද? Shift to right side than the main scale 0. Main scale 0. I got that is a positive zero error. Okay, before draw these diagrams, tell me what are the reasons? What are the reasons for positive zero error? Matakai. Sorry, not remember. Can you imagine? What are the reasons? What are the reasons? What are the reasons? Okay, before that, I will show you what's the meaning of the positive zero error. Now, xenon, if we do in normal room temperature, without temperature, if we measure without temperature change, okay, this is a positive zero error. Hari, make a balana kamang hitan. What are the possible reasons? Possible reasons. Okay, this is a positive zero error. Think now external jaws are contact, but main scale 0 and Vernier scale 0 not coincide. And Vernier scale 0 shift right side than the main scale 0, right? Shift right side than the main scale 0. Okay, what are the possible reasons? What are the possible reasons? What are the possible reasons? Shift right side than the main scale 0. What are the possible reasons? What are the possible reasons? මොනවද හේතු? මොනවද causes?
Malfunction of the parts of the parts.
No, not malfunction. It's a type of malfunction, but it has a specific reason. It has a specific reason. Very good, Hasan. Very good. Very good. That's the reason. Now think dust particles or oil or grease or rusting particles or whatever particles apply between these external jaws. What happened? Wait, I will get a paper part. Now it is a small paper. Now like this, small smooth layer apply between these external jaws. Apply mean rusting can mean corrosion. Normally these vernier calipers are made by stainless steel to avoid rusting, but when we use more than 7-8 years, this steel also rusting, corrosion. Okay, due to that, what happened? Smooth layers forming between external jaws like this. Something apply. That's the reason actually. Something apply. While something apply between external jaws, while contacting, what happened? It has additional layer. Like this. It has additional layer. That's the reason. Okay, I got. That's the reason. Remember? That's the reason. If there are no any additional layer, what happened? The Vernier scale shift to the Vernier scale come to this level. Due to this additional layer, it's stopping before come to the main scale 0. තේරුණාද? හරිනම් ඒ layer එක නැත්තම් මෙයා මෙතනට එන්න ඕනේ. Due to this additional layer, what happened? The Vernier scale stopped before come to the main scale 0. That's the actual story. I got understood. The reason, xenon, something apply between external jaws. That can be rusting, it can මලකඩ කන්න පුළුවන්. That can be something apply, dirt particle or dust particle, grease particle or oil particle, whatever. Clear? Ashini. Alindu. Rashmita. Clear? I clear? Something apply between external jaws. That's the reason. Okay, write down here. This is, sorry, this cause due to something apply between external jaws. Oh, sorry. Something apply between external jaws. Within bracket, dust particle dust particle, comma, oil strain, comma, grease particle, close bracket. Something apply between external jaws or corrosion mean rusting, corrosion of external jaws, corrosion of external jaws, or rusting of external jaws. Okay, they are the possible reasons for positive zero error. Are you complete? Okay, now go to previous page. Page number 6. And draw this. And before that, please understand this. This is the most important part. This is a basic concept. When the outer external jaws of vernier caliper contact each other, the vernier scale 0 shift right side than the main scale. This is a positive zero error. What is the reason? Something apply between external jaws. Okay, please draw this. If you don't have to, please adata vitarak pothe endaganna. Draw on your notebook with positive zero error topic. Before next week, I will solve all problems. Akhil, understood? Who is other news? Hashini, no? Hashini, I got. Okay. Complete, right? Please make sure to coincide one value, one part. Okay. This is coincide. Keep this coincide value. At least one value, actually one part need to be coincide. Hurry. Now, think I have a mid vernier caliper. The instrument has positive zero error. Then what I can do? I have vernier caliper, but it has a positive zero error. Now I can find positive or negative. How I can find positive or negative? While contacting external jaws, what happened? Main scale 0, sorry, vernier scale 0, shift right side than the main scale 0. right side than the main scale 0. Okay, then I have understand it has a positive 0 error. Okay, positive 0 error එකක් තියෙනවා. Then what I can do? Can't I use this instrument? No, we can use this instrument. Okay, your first step, first read the positive 0 error. 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 I'll write in short form for my space. Positive 0 error. Read the positive 0 error. That is your first job. Okay, then now I think you got the first step. Before use any vernier caliper, you have to contact these external jaws without any object. Contact external jaws like this, and you have to check main scale 0 and vernier scale 0. If it is perfectly coincide, no problem, you can get any measurements accurately. But if it is not coincide, you have to think it is positive 0 error or negative 0 error. Hurry. If it is positive 0 error, you can identify it is shift to right side than the main scale 0. Okay, now you have identified. Then what is your next step? You have to read the positive 0 error value first. Positive 0 error value kiyawa gannu. Okay, how to read positive 0 error value? It is very simple. It is very simple. This is a method. It is very simple. This is a method. It's very simple. This is a method. First, you can get the coincide number. Coincide number in Vernier scale. Multiply by the least count. Multiply by the least count. Least count. Very simple. Okay, coincide number. What's the coincide number of this given scale? Instrument. Coincide number 4, right? Vernier scale 0, 1, 2, 3, 4 is a coincide number. Then multiply by 10 Vernier scale parts, no? 0.1 millimeter. What's the positive 0 error? 0.4 millimeter. 0.4 millimeter is the positive 0 error. Okay, that's a method to read positive 0 error. Hurry. Steps can. What's your first step while you take measurements or any reading using vernier caliper? First, you need to check 0 errors. Check the instrument first. What's the how you can check? You have to contact two external jaws and check main scale 0 and vernier scale 0. If it is perfectly coincide, no any issue, you can get any measurement. If it is shift right side than the main scale 0, vernier scale 0, shift right side than the main scale 0, then you have to get the positive, it is a positive 0 error, you have to identify that. Then positive 0 error value, you have to read the positive 0 error value first. For this instrument, how about the positive 0 error value? 0.4. What's the method? Coincide parts multiplied by least count. Understood up to now? Very, very important this section. Therefore, try to focus very well. That 100. Hurry. Up to now, okay? Up to now, okay? Clear? Any doubt? Hurry. Then you can note down this calculation method. If you don't have tut, please note down below the diagram. If you have tut, same thing, below the diagram. complete. Hasandu, complete. Yeah. Okay. Now tell me, very carefully think. Now if I ask this type question, now this instrument has positive zero error and it is coming with something due to something applied between external jaws. Positive zero error coming due to something applied between external jaws. Okay, now I have instrument with positive zero error. This is the instrument with 0.4 millimeter positive zero error. Now, if you got any reading or any measurements, now think this is the instrument. This is the instrument I have. It has positive zero error. Positive zero error. Now I am going to get the external diameter of this slit. External diameter of this slit. Is this instrument given reading accurate? Is it accurate? Is it accurate? No. It is not accurate because the instrument has error. Now tell me my question. Is this given reading, instrument given reading? Now it has positive zero error 0.4 millimeter. Is this given reading? It is more than accurate reading or less than accurate reading? The given reading of the instrument, reading it is more than accurate reading or less than accurate reading? Think. Carefully think. More than accurate reading. Yeah. Now you already know it is not accurate. It is not accurate. I asked the instrument given reading, is it more than accurate reading or less than accurate reading? Very good, Hasandu. Very good, Tarindi. Yes. Very good. Very good. Yeah, Rukshan. Very good. All are correct. It's more than accurate reading. What's the reason? Something applying, the measurement coming, the instrument given measurement with additional layer. Additional dust or corrosion or layer with additional layer. Therefore, it is always more than accurate reading. May instrument given reading always more than accurate reading. If it has positive zero error. May it's always greater than accurate reading. May the reading shown by the caliper greater than the true value. Greater than the true value. Greater than the true value. Okay. It's greater than the true value. Hurry. Think. Now instrument has positive zero error 0.4. Now using this instrument, I got reading measurement. I got a measurement 15.8 millimeter. 15.8 millimeter I got reading. Now is it not accurate? It is not accurate. It is more than accurate reading. Now what is accurate reading? Now what is accurate reading? Can you find accurate reading? Very good. Dhammamayula. Very good. It is, yeah, this is a method. Now the reading, the instrument given reading more than accurate reading. Therefore 15.8 subtract 0.4 is the accurate reading. Then you can get the accurate reading 15.4 millimeter. Very good. All are correct. 15.4 millimeter. 15.4 millimeter is the accurate reading. Perfect. Perfect. Hari. Okay, therefore, for correction, observed value subtract positive zero error. Observed value means instrument given reading. positive 0 error. Positive 0 error. Okay, that's the method. Okay, I have given example. No? If the observed reading, instrument given reading 25.4 millimeter and positive 0 error 0.2 millimeter. Then for accurate reading or correct reading 25.4 minus 0.2, it is 25.2 millimeter. This is accurate. This is accurate reading 25.2 millimeter. 25.2 millimeter is the accurate reading. 25.2 millimeter is the accurate reading. Okay, if you want, please note down another example. Make it layagan. Positive 0 error. Positive 0 error 0.4 millimeter. Write down like this. Positive 0 error 0.4 millimeter. Method. Note down here. Method in the under. If you don't have to, no problem. And note down below. Positive 0 error 0.4 millimeter. The instrument given reading 15.8 millimeter. Accurate reading 15.8 minus 0.4 millimeter. It is 15.4 millimeter. 15.4 millimeter. Hurry. Do you have any doubt up to now? Please send me if you have any doubt up to now. Hurry. Okay, it's easy. Hurry. Now I will give you a short method to identify and remember this. Other than other, do you know the straight line like this? Straight line. This is a straight line like this. This is a straight line, right? And this is 0. What is the right side? What's the right side? They are positive 1, 2, 3, 4. Then you can easily remember Vernier scale shift to right side, it is positive 0. Now you can understand what happened if it is shift to left side, it is negative 0. Negative values. Short method. If it is shift to right side, then main scale 0, it is positive 0. It's short. It's a trick to remember. Hurry. The positive 0 error is done. Positive 0 error done. Okay, can you read this positive 0 error? That one also 0.4, no? No. Can you read this? What's the positive 0 error? Point. No, Hasalu. Check again. Positive 0 error. No, Shiva. Now correct. Shiva, how to get the positive 0 error? It's always 0 point value, Hasan. Shiva. This is a method. Get coincide parts. 0, 1 not coincide, 2 not coincide, but 3 coincide. Then 3 multiplied by 0.1 least count. It's 0.3 millimeter, not 3 millimeter. Okay. Coincide part multiplied by least count. Always least count. It's compulsory. Compulsory. Coincide parts multiplied by least count always. Hurry. Hurry. Final topic today. Negative zero error. Now you can understand what's the meaning of negative zero error. The opposite side of all what we discussed. All parts what we discussed. Hurry. Positive zero error. Sorry, negative zero error. This is a negative zero error. Very simple. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it's continue up to 150 millimeters. Okay. Negative zero error. Yeah, I will give you questions after discuss negative zero error. I'll give you questions. And next week we discussed few questions and go to next instrument. Today we can complete the Vernier caliper. Vernier caliper. Hurry. Now, what's the negative zero error? Now, if it is perfectly accurate, sorry, if it is perfectly coincide, no any zero error. If it is shifting to right side, then main scale 0, it's positive zero error. Then you can understand what's the negative zero error. The Vernier scale 0 shift left side than the main scale 0. 1, 2, 3. This is the negative zero error. Okay, what you think while contact two external jaws, what are the possible reasons to shift left side? Now, positive zero error, something apply, no? What are the possible reasons? What do you think, Rukshan? What are the possible reasons? What are the possible reasons? Very good. What's the name? Nitir. Nitir, very good. Yeah. Wearing out. නැත්නම් අපි කියනවා ගෙවීම තමයි reason. Wearing out. That means while using several years continuously, when we take continuous measurement, what happens? Smooth layers between these external jaws are removing with these measuring instruments, measuring objects. Therefore, what happens when we contact these two external jaws, what happened? Vernier scale 0 shift left side than the main scale 0. Vernier scale 0 shift left side than the main scale 0 like this. Left side. Additionally moving. If it is correct, need to be stopped here. But it is additionally moving. Additional movement. I got additional movement. That's the reason. Additional movement. Before that, when the outer jaws of Vernier caliper contact each other, the 0 of the Vernier scale shift behind Pitipas, shift to the left of the main scale 0. That's the meaning of the negative zero error. Clear? Negative zero error. This is caused due to write down due to removing of smooth layers, removing of smooth layers of external jaws while using continuously few years. That's the reason. While using continuously, smooth layers of external jaws removing with measuring objects. Hari. Now for positive zero error, what is the reason? Something applied. Negative zero error, layers removing. Remember, No, adding too much pressure to jaw. No, if I apply additional pressure, then this is a part of fixed jaw, Hasandu. This is a part of this may external jaw. It's a part of fixed jaw. If I apply additional pressure, there is no any change. Again, we can't change. Maybe we can't change again. No, while measuring, it is not error. Sorry. While measuring, if you add additional pressure, it is not a instrument error. It's a human error. We can discuss in the final part. Now we are discussing about instrument errors. This positive zero error and negative zero error, they are instrument errors. If I apply additional pressure on this object, it's a human error. Human to human, person to person, the pressure can be changed. That's a human error. Okay. Yeah. Zero error is not like that. They are fixed error. It has a fixed value. It's an instrument error. Okay. Now, you know what's the meaning of negative zero error? While contact external jaws of vernier caliper, vernier scale 0 shift left side than the main scale 0 due to some smooth layers removing. Okay, as I explained in positive zero error, before take any reading, what's the first step? Check the instrument. If it is coincide perfectly, 0, 0 coincide perfectly, no any issue. If it is shift into right side, vernier scale shift into right side, it's positive zero error. You can get the reading if you can get the positive zero error value. If it is shift to left side, you have to get the negative zero error value first. That is the most important thing on the diagram. This is the most important thing. You have to get the negative zero error value first. What is the negative zero error value? Read the negative zero error value first. Read the negative zero error value first. Okay, how to read negative zero error? What do you think? How we can read negative zero error? Now you already know how to read positive zero error. What do you think? How to read negative zero error? අපි කොහොමද read කරන්නේ? The zero error value, negative zero error value. No. We can correct the correction. We can do by adding. Just correct. I want before adding Chevan, we have to get the negative zero error value. අපි value එක අරගෙන add කරන්න වෙන්නේ. Yes. I'm asking how to get. No, that's a problem, Hasan. For subtraction or adding, we have to get a value. Yeah, Shivan. You are correct. Observed reading plus zero error. But before that, we have to get the zero error, right? I'm asking that. ඒ කියන්නේ zero error එක අරගන්න නැතුව add කරන්න value එකක් නැහැ. First we have to read the zero error, then you can add to the observed reading. Yes. Any idea? හිතන්න. How to get positive zero error value? Get coincide number multiply by zero least count, right? Coincide number and multiply by least count. How to get negative zero error? Negative zero error. How to get negative zero error value? Okay, remember that's the method. We have to get first total Vernier scale parts. Important, eh? Total Vernier scale parts. Total Vernier scale parts. Subtract coincide part. Coincide part. Multiply by least count. Multiply by least count. This is a special method. For negative zero error, you have to follow this method. You can't multiply coincide value by least count. You have to get first total number of Vernier scale part. It is 10. Coincide part 1, 2, 3, 4, 5, 6, 6. It's 4. The 10 minus 6, it is 4. Multiply by least count 0.1 millimeter. 4 multiplied by 0.1 millimeter. Okay, that's a method. It's coming 0.4 millimeter is the positive zero error. Understood? Understood? Sorry, negative, not positive. Negative. Good. Okay, note down. Okay, first draw this diagram on this box, on your box or your writing book. Then write down this calculation. Done. Okay, let's get another 10 minutes only. We can complete the vernier caliper today. Hi. Okay, then how you can identify a negative zero error? If it is while contact to external jaws, if it is vernier scale 0, shift left side than the main scale 0. What is the reason for negative zero error? Removing smooth layers or wearing out. Hari. Okay, now tell me. Now I have vernier caliper. I have a vernier caliper. It has negative zero error. Negative zero error. Okay, I'm going to get the diameter of this lid again. Then tell me the instrument given value more than accurate reading or less than accurate reading. It is not accurate. The instrument given reading not accurate. Is it more than accurate reading or less than accurate reading? More than accurate reading or less than accurate reading? Very, very good. Now, Shiva, think again. It's less than accurate reading because some smooth layers removed. Smooth layers removed. It's less than accurate reading. Yeah, because some smooth layers. Harina, Shivan, if it is correct, the vernier scale need to start from this point. Need to be start from this point, this level. But it is starting from behind the main scale value. Put a PT pass. Then always it is less than the main accurate value. If any instrument has negative zero error, it's always given less than reading the accurate reading. Less than. Shivan got? Understood? Yes. It is less than accurate reading. It is less than accurate. Again, it's adui. It's less than. Adu ekak tama hambe. Okay. Read this. The reading shown by the caliper is less than the true value. If it has negative zero error, it's less than the true value, correct value. For correction, what I can do? For correction, the observed value add to the zero error. This negative zero error add to the observed value, then you can get negative zero error add to the observed, the instrument given value, then you can get the accurate, correct reading. Okay, I have given example. If the observed reading 25.2, negative zero error 0.2 millimeter, what's the correct reading? 25.4 millimeter. Adding. Remember, another short method. I told positive negative story you can remember by straight line. 0. If it is shift to right side, they are positive. No? They are positive. If it is shift to left side, it is negative. Negative. Easy method to remember. And remember, if it is positive zero error, always you have to subtract to accuration. Always you have to subtract to accuration. Opposite. If it is positive zero error, you have to subtract to accuration. If it is negative zero error, you have to add for accuration. Remember? Matakai. Remember? This point is very important for identification of positive and negative zero error and correction method. Very good. Very good. Okay. Wait, I'll give you a few exercise. Okay, this is a normal accurate instrument. Accurate instrument. Oh, what happened? Okay, this is a accurate instrument. 0 to 0 coincide. 0 to 0 coincide. The main scale and Vernier scale like this. See, 0 to 0 coincide. It's accurate one. No any zero error. No any zero error. Tell me, what is the type of the zero error? Positive or negative? What's the type of the zero error? It's positive. And can you send me positive zero error value? Positive zero error value. Very good, Hashini. Very good, Nitira. Nitira. Hasidu correct. Sinon correct. No, Shivan. Multiply by least count. Coincide part. Multiply by least count. You have to multiply by least count. Yes, thoroughly correct. Yeah, you correct. Always in positive zero error or whatever zero error, coincide part, you have to multiply by. Yes, now correct. 0.6. And Chevan, always remember the least zero error is very small value. It's 6 millimeter. It's a very small value. It's very small value. Remember. Yes, it is positive zero error. 0.6 is the positive zero error value. Really. Okay, that is the actual reason. Something apply between these external jaws. That's the actual reason for positive zero error. This is a good question, right? That was exam question. Give me a second. Okay, that was an exam question. This is the this is a accuracy check. That means zero error. This is a zero error. This is the instrument given reading. Instrument given reading. That was an exam question. Instrument reading. Instrument reading. Can you instrument reading? Okay. First tell me, what is the type of zero error? Is it positive or negative? Positive or negative? Positive zero error. Correct. How you can identify? Positive zero error. Very good. Positive zero error. How you can identify? It is shift to right side. Now tell me, what is the positive zero error value? Positive zero error value. 0 point. Very good, Shivan. Now correct. 0.3 millimeter. Very good. No, Nitira. It is 0, 0, 1, 2. Here. I believe. 0.3 millimeter. Yes. Now, this is the instrument given value. This is the instrument given reading. This is the instrument given reading. What is this given reading? Observed reading. This is the instrument given reading. What is this reading first? I'm asking instrument given reading value. No, Hasandu. Again, you did same mistake. Iban. Read this instrument. Yes, you answered correct, but you have to mention unit. Shivan, correct? No, Hashini. Please check again. I want just instrument given value. Reading. May make a pen and reading ke maton. Is the answer correct? Yeah, what is this reading? The main scale value 40. Main scale value 40. Then coincide 1, 2, 3, 4, 5, 6. Coincide at 6. Now 40 plus 0.6, 40.6 millimeter. Now, is it accurate? Is it accurate? Now correct, Hashim. Is it accurate? No, it is not accurate. Now, can you tell me what is this accurate reading? That was exam question. That was accurate. Accurate reading was the exam question. Very good. What was accurate reading? Very good. Now it is positive zero error. The 40.6 is the reading, instrument given reading. If you need accurate reading, we have to subtract 40.6 minus 0. Positive zero error. Positive zero error. Therefore, we have to subtract. If it is positive zero error, subtract. Negative zero error, adding. Opposite. It's easy. Yeah, 40.3. 40.3. Good. Okay, that's the actual negative zero error. Actual negative zero error. What's the reason? Some layers removing, wearing out. Yes, very good. Answer. Correct. Okay, can you read this negative zero error? Isn't wrong? Yeah, that's a mistake you're doing in exam also. First, see what is the zero error type. Is it positive or negative? Nitira correct. Negative, yes. It's a negative zero error. I want negative zero error value. Hashini correct. Yes. Yes, Ola correct. No, Yansiru. No. Please follow this equation. No, Shivan. No. Say not correct. What is the equation to read negative zero error? Now positive zero error complete. Negative zero error. What's the method? Get total Vernier scale parts. How about total Vernier scale part? 10. subtract coincide number. 1, 2, 3, 4, 5, 6, 7 is a coincide number. Multiply by 0.1. It is 0.3, not 0.7. exam. First, you have to find, is it negative zero error, positive zero error? If it is positive zero error, no problem. You can use your method. What's the method? Coincide part multiply by discount. But if it is negative zero error, you have to get the total Vernier scale parts and subtract coincide parts multiply by discount. Shivan, okay? Hari? Okay, we have another 2 minutes, no? Okay, I will show you actual instrument. Wait, I get only 2 minutes. This is a negative zero error. Okay, what's the meaning of negative zero error? While contact to external jaws, this is a negative zero error. Vernier scale 0, left side than the main scale 0. Additionally shifting, no? If it is correct, need to be stop here. But it is additionally shifting. Additional shifting. Okay, quickly read this negative zero error value. Quickly read this negative zero error value. Quickly. No, Shivan. Again, same mistake. Now correct. Is on the correct? Jansilu correct? Tarindi correct? Yes. Ola correct. I think now you got the full idea of today's lesson. Okay, positive zero error and negative zero error. There was 2 exam questions. Okay, I will send these 2 exam questions as a homework into group. I will send 2 photos into group, 2 MCQ questions. Okay, you can work on this, and this is a homework for today, this week. And please go through again, and please make sure to continue your 45 minutes working time. Okay, minimum per one subject every day. You have to continue your, that minimum time is a 45 minutes. Okay, not maximum. Minimum you have to get 45 minutes. If you can get 2 hours per one subject, it's perfect. If you're not working at least 45 minutes, please separate with your other works. Please get 45 minutes at least time of your daily works for one subject. Otherwise, in final few months, it will be very difficult, and it will be very tough process to work on these subjects. Okay, therefore don't get these tricks. And I told first day, this is a most important exam of your life. Okay, the everything after this exam depend on this result, and your result and your island rank and district rank. Your university, your future, your entire life, your job and your job location. If you're working Sri Lanka or you are going to another country, everything depends on this exam result. Everything depends on this result. Therefore, please continue your works every day. හැමදාම වැඩ කරන්න තියෙන daily work. Daily working, please keep your work continuously. Right. Do you have any doubt today lesson? Okay, that's the end of Vernier caliper. That's the end of Vernier caliper. Next week we are going to start. Next week we'll start micrometer screw gauge, our new measuring instruments. Micrometer screw gauge, and you have 2 homework questions today. I'll send before tomorrow morning into our main community, main group. Okay, any doubt? Without tooth problem, any other issue? Yeah, tooth problem I will solve within this week. Today is Sunday, tomorrow morning I will solve. Hasandu, you have to send me my WhatsApp. මේ chat එක තව ටිකකින් නැති වෙනවනේ. Okay, everything clear. Okay, let's meet next week with our new instrument, micrometer screw gauge. Goodbye. Good night.